Bismillahirrahmanirrahim. Assalamu alaikum dear students. We are now starting the first lecture for the week 10 of wireless and mobile communications. In this lecture we will discuss various multiple access techniques for wireless communications. So let us start our discussion by differentiating between the terms multiplexing and multiple access. We have previously used the term multiplexing repeatedly. The term multiplexing refers to set of techniques that enable sharing of channel among multiple users. So multiple users, they are allowed to transmit the signal over a common channel, and in this way the overall the bandwidth efficiency or overall bandwidth utilization of the channel is improved. So we get a greater capacity in the system because we have efficiently used the bandwidth. Generally this multiplexing refers to the users where we have kind of localized users. So generally all the users which are using this multiplexing technique, they are at the same location, and they access that common channel by using a common access point. Whereas the term multiple access is also a form of multiplexing, but generally this multiple access is used in the case where we have users which are geographically dispersed. So these geographically dispersed users, they are allowed to transmit the signals over a common channel in order to better utilize the bandwidth of the channel. So primarily these two techniques, multiplexing and multiple access, they do the same purpose, but multiplexing is generally the term multiplexing is used where we have localized users, and multiple access is used when we have remote users. So a user in multiple access is allowed to access a remote resource available at some other location in order to transmit over a channel. So multiple access permits the communication resources to be shared by a large number of users. One important thing that we take care during the multiple access is that the sharing of resource should be made in such a way that there should be minimum interference among each user. So we should arrange the system in such a way that they do not interfere with each other. The common multiple access techniques which are used nowadays are frequency division multiple access, time division multiple access, and code division multiple access. And depending on the bandwidth allocation in a multiple access system, these systems are characterized on the basis of narrowband system or wideband systems. So let us start discussion with narrowband multiple access systems. In narrowband system, the bandwidth of a single channel is smaller than the coherence bandwidth of the channel. So we have a channel which contains a large bandwidth, and the signal which has to go through that channel, it has a smaller bandwidth. In that case, the overall radio spectrum can be divided into smaller number of narrowband channels, and each narrowband channel can be used to carry a single narrowband signal. Commonly we use frequency division duplexing in these narrowband systems, but in some cases we also use time division duplexing. In order to minimize the interference, because in duplexing we are talking about two different links, forward and reverse link. In order to minimize the interference between these two links, we need to make a split in the frequency so that the frequencies allocated to forward and reverse channels, they are different or significantly different, and do not cause interference with each other. We have two types of narrowband system. Normally either we use frequency division multiple access in narrowband system or time division multiple access in narrowband system. The narrowband FDMA systems assign different frequencies or different frequency channels to each user, so that they can use that channel to transmit their signals, and this assignment is made in such a way that the same frequency is not used by any other user in the vicinity, so that it does not cause any interference. On the other hand, narrowband TDMA system, they allow users to share the common frequency channel, but allocate different time slots in to each user in a cyclic fashion, so that each user get a turn to transmit the signal onto that common channel. So let us quickly recall the duplexing, because in order to have two-way communication, we need to have duplexing, because we have to carry two types of signal, one in the forward channel and second in the reverse channel. In duplexing, we generally use either frequency division duplexing or time division duplexing. For frequency division duplexing, those forward and reverse link, they are assigned two distant frequency bands, and there is a frequency split between these two, and you can see that this frequency split is essential in order to avoid interference between these two channels. So this reverse channel is a simplex channel, and forward channel is also a simplex channel, but combined together they represent a duplex channel that can be used to simultaneously communicate in both directions. Similarly, in time division duplexing, the users, the forward and reverse channels, they use the same frequency. However, the time is divided in different time slots, and the users or the mobile stations, they are allowed to transmit in the relevant slot as well. So one slot is reserved for forward channel, and the other slot is used for reverse channel, and then it repeats. So one time the mobile station transmits signal to the base station, and then the base station would transmit signal to the mobile station, and in this way the duplex communication is achieved by TDD. Here is the logical separation for different types of narrowband schemes. So if we have FDMA with FDD, means we have frequency division multiple access with frequency division duplexing. So in that case, each users is defined different frequencies. So each user is allocated a frequency. User 2 would be allocated a different frequency, user 3 would be allocated a different frequency, and for user 1 we would be having two different frequencies allocated to them, one for forward channel and one for the reverse channel. Similarly, if we use FDMA with time division duplexing, in that case different users, they are allocated different frequencies. User 1 is allocated different frequency, user 2 is allocated different frequency, and all the users, they are allocated different frequencies, but the forward and reverse channel for the single user, they share the same frequency, and the transmission in forward and reverse direction is made at different time slots. Similarly, if we have time division multiple access with frequency division duplexing, in that case different users, they are assigned different frequency, different time slots. So user 1 would transmit in a first time slot, user 2 would transmit in second time slot, and so on. The nth user would transmit in nth time slots. But the forward and reverse channel for each users, they can be transmitted at the same time, because they would be separated by different frequencies. So each user would be allocated two different frequencies, one for forward channel and second for the reverse channel. Similarly, if we have time division multiple access with time division duplexing, in that case each user is given different time slots for transmission. So user 1, user 2, user 3 and so on, they are allocated different time slots, and within the time slot each user have two different sub time slots which are reserved for forward and reverse communication. So forward and reverse channels, they are also divided in times. Let us now move on to the wideband multiple access system. In wideband multiple access system, the transmission bandwidth of a single channel is much larger than the coherence bandwidth of the channel. So this system is somewhat similar to what we have observed previously in spread spectrum techniques, and it has the advantages that we discussed in spread spectrum multiplexing, spread spectrum modulation as well. This wideband system, they are good to combat fading, because fading generally affect only a narrow band portion of the received signal, and overall effect is negligible for the fading. In wideband systems, users are allowed to transmit over a large part of the spectrum. The transmission is done at a relatively larger bandwidth, but we allow simultaneously many users to transmit on the same frequency or same channel. So at the same time, we have certain number of transmitters which would be transmitting the signal. For wideband system, we either use time division multiple access technique or spread spectrum code division multiple access technique. In time division multiple access, many users, they are allocated different time slots to transmit the signal. Similarly, for spread spectrum technique or code division multiple access technique, different users, they are allowed to transmit simultaneously at the same time, because they are allocated different codes for transmission over the same channel. So there are different codes allocated to each signal, like we have discussed in spread spectrum technique, that we generally allocate a pseudo random code to each of the signal, so that it can be spread in frequency domain, and multiple signals, they can be transmitted at the same time. In both cases, for TDMA and CDMA, the duplexing can be either FDD or TDD. So we can either have frequency division duplexing or time division duplexing for both TDMA or CDMA based wideband systems. So this is an illustration of logical separation between different systems. So if we have TDMA based multiple access and frequency division duplexing, in that case different users would be allocated different time slots for the transmission. So user 1 would have a certain time slot for transmission, user 2 would have another time slot for transmission, user 3 would have another time slot for transmission, and so on. Each user would be allocated a different time slot for transmission. But for each user, we generally have allocated two different frequencies in order to establish forward and reverse communication. So forward channel and reverse channel, they have different frequencies for each users. Similarly, if we have time division multiple access but time division duplexing, in that case different users, they are allocated different time slots. So each user 1, user 2, user 3 and so on, they are allocated different time slots for the transmission, but each time slot is further divided into two sub time slots to establish forward and reverse communication. So we have forward channel and reverse channel separated in time as well, in addition to the different users which are allocated different time slots. For code division multiple access based and FDD based system, so if we have code division multiple access but frequency division duplexing, in that case different users, they are allocated different codes. So this axis is now represent code. So user 1 would have would have a specific pseudo random code, user 2 would have another pseudo random code, user 3 would have another pseudo random code, and so on. So different users, they are allocated different pseudo-random codes, and each user is allocated 2 frequency channel to establish forward and reverse communication. So we have one frequency allocated for forward channel and another frequency for reverse channel. Similarly, if we have code division multiple access but time division duplexing, in that case different users, they are allocated different codes, as I discussed before. So user 1 would have a specific pseudo-random code, user 2 would have a different pseudo-random code, and so on. Each user would have different pseudo-random code, but the duplex channel, they are at different time slots. So different time slots are allocated to establish forward communication and reverse communication. So we have 2 different channels to establish forward and reverse communication in a different time slots. So this is the logical separation between wideband multiple access system. So quickly summarizing, so we generally have either narrowband system or wideband system. In narrowband systems we use either FDMA or TDMA. In wideband systems we either use TDMA and CDMA. And for duplexing, for all cases we either use frequency division duplexing or time division duplexing. This is a summary of different multiple access techniques being used for different wireless systems, which has been used previously in different standards. So you can see that different duplexing and different multiple access techniques were used in different systems. For EMS or first generation systems, we used frequency division multiple access and frequency division duplexing. For GSM, normally the multiple access is time division, but duplexing is frequency division. For US digital cellular, the multiple access technique is time division multiple access, and duplexing is frequency division duplexing, and so on. For different systems we have this different types of techniques which are being used to provide multiple access as well as duplexing in that systems. So let us now briefly discuss each type of multiple access techniques separately. So we start our discussion with frequency division multiple access. In FDMA systems, each user is allocated unique frequency band or unique channel. Generally, these channels are allocated on demand basis to each user. So whenever a user requests a channel, it is allocated to that particular user. But once a channel is allocated, during the period of that call, no other user is allowed to transmit on the same frequency band to avoid interference. In general, in FDMA channel, if it is not in use, so it cannot be used by other users, because if they are using another channel, so they cannot use any free channel as well. So eventually it results in a waste of resource as well. The good thing about FDMA system is that it has a relatively low complexity as compared to the TDMA systems, although this scenario is gradually changing because of the improved DSP methods which are available for TDMA systems. So let me quickly summarize important features for FDMA systems. The FDMA channel carries only one phone circuit at a time. So at one channel we can establish only one communication link for that particular time. After assignment of the voice channel, once you have assigned the channel to a specific user, both base stations and the mobile station, they transmit simultaneously and continuously, because to use that channel properly. So this FDMA scheme is based on a continuous transmission system. The bandwidth that is used for FDMA system is generally relatively narrow bandwidth, which is around 30 kilohertz only. The symbol time used in FDMA systems is relatively large as compared to the average delay spread achieved in the wireless systems. So generally for FDMA systems we do not have significant inter-symbol interference, and this type of system they do not require any type of equalization to compensate for this type of inter-symbol interference. Being a continuous transmission system, because the transmitter and receiver, the base station and mobile equipment, they are transmitting continuously, this FDMA system does not require any overhead bits. So we do not need any specific bits to synchronize or framing for the signal which are needed in the TDMA systems. FDMA systems they incur a relatively higher cell site cost because we need to have a single channel per carrier design, and we need to implement good quality and costly band pass filter to extract different signals at different frequencies. Generally in FDMA mobile unit we need to use duplexers in order to establish communication in both directions. So these duplexers they are implemented so that the communication in forward and reverse direction is achieved at the same time. So transmit and receive signal they have to be managed by that duplexer. This use of duplexer in the mobile equipment generally increased in overall cost of a FDMA subscriber unit and the base station. In order to avoid the adjacent channel interference for FDMA systems, we generally need to have relatively good quality filters. These high quality RF filters are needed so that we do not have significant amount of interference. So let us take a simple problem related to FDMA system. Let's say we have a FDMA system where the total allocated spectrum is 12.5 megahertz. For this 12.5 megahertz, a 10 kilohertz guard band is allocated at the edge of the allocated spectrum. So this 10 kilohertz guard band at both sides cannot be used for any transmission purposes. So we need to estimate how many number of channels we can get with this FDMA system if each of the channel it has a bandwidth of 30 kilohertz. You can see that the total available bandwidth, which is represented by BT, and at the end of both ends of this transmission allocated bandwidth, we have a guard band which cannot be used for transmission. So this 2 times B guard cannot be used for transmission purposes. So the available spectrum for transmission is given by BT minus 2B guard. And we want to divide this available band in a smaller channel, each having bandwidth of 30 kilohertz. So we have to divide this by 30. So the number of channels that we get from this FDMA system is given by BT minus 2B guard over BC. And if you substitute the value, this BT is 12.5 megahertz and B guard is 10 kilohertz and BC is 30 kilohertz, and if we simplify, we would see that the number of channels that we get from this FDMA system is equal to 416. And if you refer back to the summaries in first chapter of the textbook, you would see that in US each cellular carrier was allocated 416 channels in FDMA systems. So this was a problem related to the FDMA system. Now let us move on to the discussion on a TDMA system. For time division multiple access, all the users, they use same frequency band. You can see that at the frequency axis there is no division. Similarly, at the code axis there is no division here, but at the time axis we have divided the time axis into different time slots, and each time slot is allocated to different users. So first time slot represents first channel, second time slot represents second channel, and third time slot represents third channel, and so on. So in each time slot only one user is allowed to either transmit or receive the data. Because each user has to transmit in an allocated time slot only, so it cannot transmit at other time slots. So at those time slots it has to store the data. So transmission system is generally based on a buffer and burst method. So we generally have a burst transmission at the specific time slot, and for the other time slots the transmitter has to store the data, and it has to wait for the appropriate time slot to come for the transmission purposes. So the transmission would be allowed in a burst method at the given time slot only. And you can see that unlike the FDMA system, the transmission in TDMA system is non-continuous, because the users, they do not continuously transmit system data. They only transmit at specific time instances. So generally this type of system results in a better battery consumption, because it does not require significant battery at the time when there is no transmission. The transmission from various users is generally interlaced into a repeating frame structure, which is transmitted over specific time slots. Although we generally use analog transmission for FDMA system, but that analog transmission cannot be used for TDMA system. The TDMA must be based on the digital data and digital modulation schemes in order to have successful transmission. So let us quickly summarize some of the important features related to TDMA systems. So TDMA share the single carrier frequency with several users in a non-overlapping time slot. So each user is assigned a dedicated time slot, and it has to transmit their data onto that specific time slots, and these time slots, they are set in such a way that they do not overlap with each other in order to avoid any interference among different users. The good thing about the TDMA system is that when it's not transmitting the data, it has opportunity to listen or monitor the other base station during those idle time slots when there is no transmission from the user. So that monitoring of base station generally facilitate in the handoff process. So in that case, the mobile station generally contribute to the handoff process. So we generally have a mobile assisted or MOHO handoff, which helps in making a better decision for handoff. Since the transmission is done at different time slots, so one time slot at one time slot we have only one type of transmission at the system, so we generally do not need duplexers in TDMA systems, which saves some cost for the mobile equipments as well. For TDMA system, adaptive equalization is usually necessary because the transmission rates are generally very high as compared to FDMA channels, and that high transmission rate sometimes results in inter-symbol interference, causing distortion in the system, and in order to compensate for that distortion, we need to have adaptive equalization in these TDMA systems. TDMA systems, they have relatively high overheads because the TDMA signals has to be synchronized with each other. So each frame which carries the TDMA data, they also have some bits which are dedicated for synchronization purposes. So these overhead bits, they add up an overhead to the system. So TDMA system generally have high synchronization overhead as compared to the FDMA system, where we do not need significant overhead for synchronization purposes. So TDMA system has an advantage that it is possible to allocate different number of time slots per frame to different users. So there is a flexibility in assignment of time slots to the user as well, and this helps in managing the bandwidth as well. So sometimes we adjust the time slots in order to better adjust the bandwidths in order to meet the demands for different users. So let us take a simple problem related to TDMA FDD based system, so which is actually the representation of GSM system. For GSM system generally uses TDMA FDD system. So if we have 25 megahertz for forward link, which is broken into channels of 200 kilohertz, so each channel requires 200 kilohertz, and we do not have any guard band. It is assumed that there is no guard band in the system as well. Each channel is divided into 8 different time slots. So there are 8 speech channels supported by a single radio channel. So at a single frequency band, we have 8 different time slots or 8 different users that can be accommodated in the one radio channel. So how many total number of users can be accommodated simultaneously in this type of GSM system? You can see that because this frequency division duplexing, and we have the frequency which has to be divided into 200 kilohertz frequency band. So if we think of only frequency division, so this represents the number of frequency channel which are available in that case, where BT is a total allocated spectrum. B guard is the guard band, which is 0 here. We do not have any guard band here. And BC is the required bandwidth for individual channel. So for this particular case, we have 25 megahertz allocated spectrum, and we want to divide it in among 200 among several channels, each of 200 kilohertz. Further, the overall number of users would also be increased because of this TDMA system, because each of the single frequency channel is further divided into 8 speech channels. This 8 speech channels is represented here, this M. So overall number of users would be multiplied by 8, because each channel would be further divided into 8 different time division based speech channels. So we have to multiply it by 8 here. So this is the overall number of channels for this type of TDMA system, M into BT minus 2 B guard divided by BC. So if I substitute all the values, you would see that we have we get number of users to be equal to 1000 for this particular case. So this GSM system can accommodate around 1000 simultaneous users to transmit using this TDMA based FDD system. So let us now move on to the third multiple access technique, which is the general form is the spread spectrum multiple access technique. This spread spectrum multiple access technique is actually same as the spread spectrum modulation system that we have discussed in our previous week's discussion. In spread spectrum multiple access, a single user or the signal, they are spread in the frequency domain. So for transmission, we generally require a relatively large bandwidth which is much greater than the minimum required bandwidth for transmission. So signal is spread in the frequency domain by using a pseudo noise sequence. It's a pseudo noise is a random code or orthogonal random codes which generally converts a signal from narrowband signal to the wideband signal, which generally appears as a noise like signal for other systems. The spread spectrum multiple access technique, it has an advantage of having better immunity to multipath interference as well as multiple access capabilities because of the wider bandwidth of the signal. Whenever there is a multipath interference or fading occurring in that transmission, so that fading generally affects a specific part of that overall signal, so overall signal does not get affected by fading, and on the average basis we do not see significant amount of fading in that spread spectrum signal. Generally this spread spectrum system is not very efficient when we have fewer number of users. For single user or few number of users, it's wastage of resource because we generally have we need a larger amount of bandwidth for transmission. However, this spread spectrum multiple access technique becomes efficient when many users they share the same bandwidth, and this is exactly what we need in the wireless systems. For wireless system design, we generally focus on the techniques which allow us to combine various users or multiple users over the limited amount of the spectrum. So this is in accordance with the need of the wireless system design that we have to use this spread spectrum multiple access technique so that we can transmit signals coming from many different users over the same bandwidth. There are two main types of spread spectrum multiple access techniques. First one is named as frequency hopped multiple access. Generally we write it as FDMA, or second we have direct sequence multiple access, which is sometimes abbreviated as DS. So we have two types of spread spectrum technique where we commonly use direct sequence multiple access technique, and this technique is also named as code division multiple access or CDMA. So CDMA is another name given for this direct sequence multiple access system because we use different codes for two different users to multiplex them with each other. So this is a basic introduction regarding the spread spectrum multiple access techniques. We would continue this discussion by having further details on this frequency hopped multiple access and direct sequence multiple access in our next lecture, inshallah. So we stop our discussion here, and we will continue the same topic in the next lecture. Thank you all.